Sa video natin ngayon, we'll try to solve problems involving simple curves. Now in our previous video, I already derived all the formulas that we will use, and so we'll just base our calculations from this figure. So copy na lang natin. And then dito sa first problem, we have the simple curve that connects two tangents AB and BC with bearings of north 81 degrees east and south 63 degrees east respectively. Now if the stationing of the vertex is 4 plus 358 and stationing of PC is 4 plus 301, we have to determine the following: the radius of the curve, the external distance, the middle ordinate, the chord distance, the length of the curve, the stationing of PT, and the stationing of a point on the curve which intersects with the line, making a deflection angle of 7 degrees with the tangent passing through the PC. Now just some important reminders: if you see this stationing, it actually means 4,358 meters. Now this is because our stationing is per kilometer, and so this is 4 kilometers plus 358 meters. And so this is what you have to remember. And so now, we'll try to draw our figure. Diba, we are given the bearings. And so, kung meron kang bearings, you will actually use that para makuha natin yung I, or yung central angle. Now, when we say north 81 degrees east, that means na from north, we'll move 81 degrees patungo sa east. And so, if we'll draw our x and y axis, we have this one. This is north, this is south, this is west, and this is east. And then, diba, north 81 degrees east. And so, let's just actually use our ruler para accurate yung drawings natin. Now, we will start from north, and then we'll move 81 degrees patungo sa east. And so 81 degrees will be this angle. This is 81 degrees. And so its complementary angle will be 9 degrees. That's why 9 yung gamit ko dito. So let's zoom in. And so let's draw a line that makes 9 degrees with respect to the horizontal. And so ito na yan. By the way, extend na lang natin to. This is actually up to this point. So this is 81 degrees. And then since this is perpendicular, this is 9 degrees. And then let's try to draw our second bearing. Diba, andito yan. Let's draw another x and y axis. And then this is east, this is north, west, and south. So for the second bearing, we have south, and then 63 degrees east. So dito tayo galing, and then we'll move 63 degrees patungo sa east. And so it will be this angle. And so let's make this 63. By the way, since this angle is with respect to horizontal, then we'll get the complementary angle. Now, diba, 90 minus 63, that will give us 27. So this is supposed to be 27 degrees. And then zoom tayo, and then we'll draw another line. Now, dapat equal to sa first tangent. So rotate natin, and then let's check if equal. And so ito na yung drawing natin. So this is 63 degrees. And so that means this angle will be 27 degrees. And then if we'll extend this line for the back tangent, again, this is our back tangent, while this is our forward tangent. If we'll extend this line, this will still be 9 degrees. Kasi diba, this is with respect to horizontal. And so since this is also with respect to horizontal, this is also 9 degrees. And so diba, yung angle between the two tangents, yan yung central angle natin or intersection angle. So this angle pala, ito yung I natin, which is 27 plus 9 degrees. So 27 plus 9, that will give us 36 degrees. So this is our central angle. And so if you were to draw a circle, that will define our curve. Ito na yan. And so diba, perfect yung tangent natin. And so erase na lang natin to. This will be our PC, and then this is our PT, and then yung center ng circle is somewhere dito. And so let's draw a perpendicular line dito, and then dito rin. Now let's just actually make this 301 so that our drawing will be accurate. And so move natin to. First, we have to determine now the radius of the curve. And so let's first define our triangles. Now diba, we can connect a line from this point patungo dito sa center ng circle, and then this angle will be 90 degrees. Saka ito rin. And so that means that this is a right triangle. Yan. Ito nakakulay purple. And so diba, dito sa properties natin, if this is I, then this angle is I over 2. And so this is I over 2, and also this one. And so considering this triangle, we can solve the radius. Again, this is our radius, this is our tangent distance, and then if we'll connect a line from PC patungo sa PT, that will be our chord distance. Now dito, we are given the stationing of the vertex, which is essentially the point of intersection. So itong point na to, this is at station 4 plus 358. So stationing is 4 plus 358. And then itong PC natin, this is at 4 plus 301. So stationing is 4 plus 301. And so to get the tangent distance, diba, alam natin na the stationing of PI is the stationing of PC plus the tangent distance. And so since meron tayong stationing ng PI which is 4358, we are just converting this to meters. we can solve the tangent kasi meron din tayong stationing ng PC. So we have 4301 plus the tangent distance. Our tangent distance will be 4358 minus 4301, which is 57 meters. Yan. And so if this is 57 meters, move ko na lang to. Then I can solve R using the tangent function. Kasi diba, this angle is also solvable. Kasi meron na tayong I. So if our I is 36, I over 2 will be half of that, which is 18 degrees. So this is 18 degrees. And so considering this triangle, let's use the tangent function. And then our angle is 18 degrees. And then diba, tangent is opposite over adjacent. And so our opposite side to this angle is the back tangent, which is 57. So equals 57 divided by our adjacent side, which is the radius. Kasi diba, this is our angle and this is adjacent. So divided by R, we can solve our radius. And so we have 57 divided by tan 18. That will give us 175.427. So R equals, let's just use 3 decimals. This will be 175.428. And then this is meters. And so this is our answer for number 1. And so next, we'll solve the external distance. Now, diba, yung external distance is from this point patungo dito. Now, again, yung external distance is outside the circle or outside the curve. So, this is E. And then, diba, this point up to this point, that's also the radius. So, this is R. And then here, we can actually still consider the same triangle. However, since this is the hypotenuse, you actually have two options. You can either use the cosine function or the sine function, or you can also use the Pythagorean theorem. And so para maiba naman dito, kasi diba we used the cosine function, we can actually use sine. And so here, if we use sine, our angle is still 18 degrees. And then our opposite side is 57, while our hypotenuse is R plus E. However, we know that R is 175.428. So we'll just change this one. This is 175.428 plus E. Now again, this is the advantage if you know the figure and you know how to apply trigonometry. Kasi if you'll only use the derived formulas, then you won't be flexible in solving problems. Dito, makikita nyo talaga na magagamit natin yung sine sa Pythagorean theorem just to solve E. And so solving E, we have sine 18 is equal to 57 over 175.428 plus E. So our E will be 9.0278. Now let's just use 3 decimals. This is 9.028. Now if you'll use the cosine function, then meron tayong cos 18, and then our adjacent side is the radius, which is 175.428. And so you can still get the same value. And then if you'll use the Pythagorean theorem, in which c squared equals e squared plus b squared, we have the hypotenuse will be r plus e, so that will be 175.428 plus e, and then squared. Now again, this is c squared equals a squared plus b squared, and then our a will be any side, whether r or t. So let's just use r, which is 175.428 squared, and then plus 57 squared. So shift solve, you'll still get the same value. So depende na yan sa'yo. Kung alam mo talaga yung figure, wala ka ng problema sa formulas. And so this is our answer for letter B. And so dito na tayo sa letter C. We have to compute the middle ordinate. Now itong middle ordinate is from this point patungo dito sa kung saan nag-intersect yung line na to saka yung chord. So our external distance is actually this distance. This is M. Now to solve M, I can actually consider this triangle. Let's color it pink. Yan. Now considering this pink triangle, this angle is actually perpendicular. And so let's first identify our sides. Now diba, this distance from here up to here, that will be R minus M. Kasi diba, this is our radius, and then if we'll subtract M, we will get this distance. And then itong side na to, this is still our radius. And so since meron akong adjacent side saka hypotenuse, then I can use the cosine function. So we have cosine of 18 degrees, kasi this is still 18 degrees. That's equal to adjacent, which is r minus m, divided by the hypotenuse, which is our radius. So this is r. And so papalitan natin to, this is 175.428 divided by r, which is also 175.428. We can now solve m. So cos 18 equals 175.428 minus m over 175.428. We have 8.586. So m equals 8.586. And so copy natin, this is for letter C. Now our next question is the chord distance. So diba, ito yan, from PC patungo sa PT. Itong line na to. And so dito, we'll still consider the same triangle, but we'll be getting this side. Now let's label this as, dito we used L over 2, so let's use L over 2, and then this is also L over 2. And so to compute L, we'll use this triangle, but we'll now use the sine function, because we now have the opposite side. So sine 18 degrees is equal to the opposite side, which is L over 2, divided by the hypotenuse, which is R. And so since our R is 175.428, we can change this. And so solving L, we have sine 18 equals L over 2 divided by 175.428. We'll get this value, 108.42. So L equals 108.42. And so this is our answer. And so next, compute natin yung length of curve. Now diba, for the length of curve, we will just use ratio and proportion. Now for a whole circle, the circumference is 2 pi r, and then the revolution is 360 degrees. And so if you are to relate that with our curve, we have the length of curve, which is essentially the arc length. Kasi diba, this is the circumference, and then we are taking a chunk of it, which is this distance, and then we'll relate that with our central angle. Now diba, yung total nito is 36 degrees. So we have LC over 36. And so since we have our radius, which is 175.428, we can now solve LC. And so we have 2 pi times 175.428 over 360, and then we can just multiply this by 36. So our LC will be 110.22 or 225. So LC equals 110.225. And so this is our answer. Now for letter F, we are to compute the stationing of PT. Now to get the stationing of PT, we have the stationing of PC plus the length of curve. So the stationing of PT will be 4301 because this is our stationing, and then plus the length of curve, which is 110.225. So plus 110.225, we have 4411.225. And so this is 4 plus 411.225. And so this is our answer. Now for letter G, we have to compute the stationing of a point on the curve which intersects with the line, making a deflection angle of 7 degrees. Now recall that this is our deflection angle, and since it is mentioned that the deflection angle is 7 degrees, then we can actually draw this line. From PC, let's draw a line going to the curve, and then we'll have this one. And then establish natin yung point, and then let's draw a perpendicular line from the back tangent patungo dito. So this is 90 degrees, and then this is our deflection angle, which is 7 degrees. Now diba dito, if we are to make a line from this point patungo sa center ng circle, the deflection angle will be doubled. And so let's draw a line from here patungo sa center. This angle will be double of this. So since this is 7 degrees, then this must be 14 degrees. Now again, this comes from 2 times 7, which is our deflection angle. And so diba, if we want the stationing of a point, and then we are given the stationing of PC, then we'll add the length of this curve to the stationing of PC. And so how are we going to compute the length of this curve? We can still actually use ratio and proportion. Now we have 2 pi r over 360 for the whole circle, and then for this particular point, we have a central angle of 14 degrees. So this is 14, and then this is the length of curve up to this point. Now let's just label this as A. So the length of curve going to point A, that will be 2 pi times r, which is 175.428 over 360, and then times 14. So that will give us 42.865. So LC going to A, this is 42.865. And so the stationing of this point will be station of A equals the stationing of PC plus LCA. And so this is 4301 plus 42.865, which will give us 4343.865. Or if we are to use plus, this will be 4 plus 343.865. And so this is our answer. Now just some additional input. What if we are to compute the offset distance x, which is this distance? How are we going to solve that? Now the technique here is we can actually consider this as another simple curve, or essentially a chunk of our simple curve. Now however, we won't actually need that because we will just consider this triangle. This is our first side, and then our remaining sides will be these distances, and also this one. Let's just actually consider this side from here up to the center. Diba, considering the green triangle, we have an isosceles triangle because this side is R and this is also R. Kasi diba, this is still the radius from the center patungo sa curve, saka ito rin. And so if I am to redraw that, we have this figure. This is the radius as well as this one. And then we actually have the value of this angle, which is 14 degrees. So this is 14. And then we'll try to solve this distance. Now let's say this is y. Now in here, since I have two sides, and then I have an included angle, I can actually use the cosine law. And so using the cosine law, by the way, our radius is 175.428. And also this. So recall that our cosine law is c squared equals a squared plus b squared minus 2ab multiplied by cos c. Now let's just actually use the small letter c to signify angle. Now c here is our unknown distance, and then the small letter c is the angle opposite to that side. Now again, whatever is outside, this will be the opposite angle to that. So we have our unknown is y. So y squared is equal to a squared, which is 175.428, and then squared plus b, which is still 175.428, and then squared minus 2 times ab. Now since our a and b are the same, we'll just use 175.428 and then we'll square this one. But just to make this clear, let me just use 175.428 times 175.428. Again, this is our a and this is our b. But don't worry, since these values can be interchanged because we are just multiplying. And then cosine of this angle, so that's 14 degrees. And so solving y, we have the square root of 175.428 squared plus 175.428 squared minus 2 times 175.428 times 175.428 cos 14. We have this value, which is 42.759. So y equals 42.759, and this is meters. However, this still isn't what we are looking for, because what we are looking for is the distance x. To solve the distance x, we will just use the sine function, because the distance we obtained earlier, itong y, it's actually this distance from here up to here. That's y. And so diba, this is another right triangle. And so if I am to redraw that, this is x, and then this is y, which is 42.759. And so this is 42.759. And then our angle is 7 degrees. So this is 7 degrees. And then since this is perpendicular, then this will be our hypotenuse, and this is our opposite side. So we can use the sine function. So we have sine of 7 degrees is equal to the opposite side, which is x, divided by the hypotenuse, which is 42.759. And so solving x, we have this value times sine 7. So that will be 5.21 meters. So x equals 5.21 meters. And then this is our offset distance. So let's copy this. And then this will be our answer for letter H. Now by the way, to solve y, you have this alternative. You can actually divide this, and then this will be 7 degrees, and then this distance will be y over 2. And then this is just perpendicular. Essentially, what happens to this is this will be our chord, because this is actually a curve. If you look at our figure, this is the chord, and this is our curve. So that's essentially just a chunk of our simple curve. And so using sine, we have sine of 7 degrees is equal to y over 2 divided by the hypotenuse, which is the radius. So we have 175.428. And so this will be sine 7 is equal to y over 2 divided by 175.428. And so solving y, we have 42.759. And so notice that this is the same as this one. And so it's up to you whether what you want to use. However, I'm just showing you both so that you will be able to evaluate what's better. And so now we'll consider a simpler problem. However, this will encompass the arc basis and the chord basis. And so we'll just copy this one. Now just to reiterate, by arc basis, we are considering one station to be 20 meters, but we are essentially looking at the arc length. However, by chord basis, our one station is still 20 meters, but we are considering the chord. And so this is what you have to remember. And so if our simple curve has a degree of curve of 6 degrees, we will now compute the radius of the curve using the two references. And so for the first one, let's say this is letter A and this is letter B. By arc basis, we have this ratio. So 2 pi r over 360 is equal to 20 over the degree of curve, which is 6 degrees. So solving r, we have 2 pi times r over 360 is equal to 20 over 6. And so that gives us 190.99, or simply 191. And then by chord basis, we actually have the following relationships. So sine of the degree of curve, which is 6 degrees, divided by 2, which is essentially this angle, that's equal to the opposite side, which is 10 meters, because one station is 20 and then we are dividing it by 2, divided by our radius, which is the hypotenuse. And so solving r, we have 10 divided by sine of 6 over 2, or 3 degrees, that will give us 191.07. And so as you can notice, the difference is just negligible. But for some values of the degree of curve, this will actually constitute some changes. And so be careful when solving problems if the radius of the curve is to be computed by a specific basis.